Alright, so we're going to look at composing functions, or the composition of functions. And all it means, I'm going to go ahead and give you the definition right here so that you know what I'm talking about while I'm doing it, is when you compose two functions, all that means is you're going to take the output of one function the input of another function. And you can actually compose a function with itself. All you're doing is everywhere there's an x in the function, you're putting the function in that place. So it's really like evaluating a function, like if we just did the synthetic substitution, where you would evaluate a function at a given value, except you're not putting in a number, you're just putting in another function. And so here's what it looks like. Here's what the function notation looks like when you do function composition. You can see it two ways. The first one, I can zoom in on that a little bit. The way that you can show functions being composed, one is this, is if you've got two functions, I'm going to do this, for f of x and g of x. If I have two functions, I can show the composition like this. That's an open circle. It looks like you're spelling the word fog. That just means I'm doing f composed with g of x, and we use that as an open circle. It's not an O like the letter O. It's an open circle between the two names of the functions. Or you can see it this way. And that looks funny because you got a lot of parentheses going on there. But honestly, that's no different than doing something like this. You're just plugging in something for the x, except in this case I'm plugging in a function. So you would write one function inside another. Okay, so here's some things that you have to be careful of. You're going to always start with the innermost parentheses. So when I say the innermost parentheses, if I was doing this type of notation, I would start with this piece. You would start here. Or if it's the other notation, you want to start with the function that's at the far right. So if I were doing this notation, I would start with this function. I would start here. So let me explain to you what I'm talking about when we start doing these. One thing that I need you to be very careful of is that if you do this, it is not always equal to this. And when I say it's not always, that means that there are occasions where those two compositions, which are opposites of each other, actually equal the same thing, but they aren't always. So the point here is to make sure you do the correct function first. Okay, so here we go. I've got three functions up here, f of x, g of x, and h of x. And I'm just going to do some composition, and I've shown both notations. I've shown g composed with h of x with parenthesis notation, and I've got f composed with h of x in that open circle notation. Okay? So it means, this number one means I'm going to try my highlighters here and see how it works for you. I'm going to take this function, this one, and put it inside. I don't know how well this is going to show up for us, but I'm going to put it inside this one everywhere that there's an x. So here's what I like to do. I like to take this function, my one that I'm putting, that's going to be the one that's going to consume the other one. I'm going to take this g function and I'm going to start it, but I'm just going to leave a blank where the x is, like that. And then this function is what's going to go inside here. This function is what goes inside. It's like the g is eating the h, so the h has to get on the inside. And if there's nothing to simplify, there's nothing to simplify. You can't do anything to the square root of 2x plus 3, so that's my answer. Okay, so that's all there is to do that. There's nothing to simplify. That's just your answer. You will simplify if possible, but you can't always. You can't do anything with that. And I think I said that already, but I had to pause the video and I don't remember. So, look at number 2, f of h of g. That means, f of h of x. That means that the f function is going to consume the h function. The h is going into the f. So my f function is x squared. So here's what I do. It's x squared. And then I take my h function and put it inside right here. My h function is 2x plus 3. Now I can simplify this one, because if you square a binomial, that means that you multiply by itself. And I don't know why I didn't put the parentheses here when I typed this. I apologize. When you do that function composition here, and I have a binomial being squared, I'm going to do 2x plus 3 times 2x plus 3. And I hate to spend my time writing it out, but I will. If you know the shortcut, then you can avoid the whole writing it out thing, and that would be to square the first term, multiply these and double them. 6x doubled is going to give me 12x, and you can see that here I'm going to get 6x and 6x when I do my distributive property. So that gives me 12x in the middle, and then square the last one. 3 times 3 is 9, and so here's my simplified answer. This is what I'm looking for. So simplify when you can. All I'm doing is whatever function's on the left is going to consume the one that's on the right. And so whatever function is on the right, you substitute it into my values of x on the left. I don't know if that makes sense or if that just confused you. But everywhere there's an x in that f function, I'm going to put that h of x function in it. So, same thing here, h of g of x. That means that everywhere there's an x in this h function, I'm going to plug that g of x into it. So here's what I do. It's 2x plus 3. That's the h function. That's the one that you're going to compose the other one into. And this function is going to go right here, because that's the g function. And so it's the square root of x plus 1. We can simplify this because I can distribute that too. And so h of g of x is 2 times the square root of x plus 2 plus 3. And then I can combine like terms. H of g of x is 2 times the square root of x plus 5. Next, f of g of x. I'm going to take my f function, which is x squared, and I'm going to plug in the g function, which is the square root of x plus 1. I can do this. So if I do f composed with g of x, then I'm going to do the square root of x plus 1 times the square root of x plus 1. And we can do this. The square root of x times the square root of x, this is old stuff, is the square root of x squared, or just x, because we've already discussed when you multiply a radical by itself, you just get the thing that's under the radical. It's just x. And the square root of x times 1 plus the square root of x times 1 is going to give me 2 times the square root of x. And then 1 times 1, sorry, I don't know how to do the equal sign. 1 times 1 is 1. And that's what I'm looking for. F composed with g of x. You're just plugging in one function for x in another function. That's all you're doing. This function goes into this one. Alright, the other part of that, and then we're almost through, is to actually evaluate it. And so I'm still using these three functions. I'm going to write them at the top of this part. F of x is x squared, g of x is the square root of x plus 1, and h of x is 2x plus 3. There are a couple of ways that you can do this. Honestly, my opinion is if you get bogged down in the whole composition thing, is to do this thing first, evaluate that function where x is 4. So I'm going to come over here and do a little bit of side work, and g of 4 is going to be the square root of 4 plus 1. The square root of 4 is 2 plus 1, and 2 plus 1 is 3. So now this is what's going into the f. So I'm going to do f of 3, and that means I'm going to do 3 squared, which is 9. So f composed, f composed with g of 4 is equal to 9. And I'm going to show you the other way to do it, okay? I can do this. I'm going to put it on a little side sheet right here. I'm going to redo it like I haven't done it yet. You can do this. Just like we were doing a minute ago, take your f function, the one that's on the left, and go ahead and get it started. But don't put the x in. Just where there's an x, leave a space. And then the g function is going to go inside here. But what I'm going to do here is I'm going to put in a 4 for the x. And so now I have this. The square root of 4 plus 1, so the square root of 4 is 2, plus 1 squared, and 2 plus 1 is 3 squared, and that's going to give me 9. And you can see I got the same thing, do it 2 different ways. You can either evaluate this first part and then take that number and plug it into the second function, or you can do it all at once. It just depends on you and what you feel comfortable with. Okay, so h of f of negative 1. I'm going to do it both ways here. I'm going to do, my h function is 2x plus 3. My f function is x squared, so I'm going to do negative 1 squared. Oh, I'm so sorry, you can't see that. I get caught up in what I'm doing here and I don't pay attention to the screen all the time. So here's what I did. My h function is 2x plus 3. This was my x. But then I'm going to plug in negative 1 for x in this one. So it's negative 1 squared. And here's what I do. So that's 2 times, negative 1 squared is 1. 2 times 1 is 2, and 2 plus 3 is 5. So h of f of negative 1 is 5. Or, I can do this. F of negative 1 is this, which is 1. And then I would plug that into my h function. And my h function is 2x plus 3. 2 times 1 is 2. 2 plus 3 is 5. And I still get I still get 5. It's whatever way you want to do it. So you pause the video right here and you do the last two, and then you come back and make sure you got them right. If you're not comfortable with that, then you don't have to pause the video. You can work through them with me. Alright, so h composed with a g of 9, that means I'm going to take my h function, which is 2x plus 3, and my g function is the square root of x plus 1, and x is 9. So I've got 2 times the square root of 9 is 3. 3 plus 1 is 4. 2 times 4 is 8. And 8 plus 3 is 11. So h composed, well, I wrote it that way. It doesn't matter. H composed with a g of 9 is 11. Or, if I do g of 9, I wrote that a little bit too far to the edge, sorry. My g function is the square root of 9 plus 1. The square root of 9 is 3. 3 plus 1 is 4. And then I would put that into, h, not f. So h of 4 is 2 times 4 plus 3. 2 times 4 is 8. 8 plus 3 is 11. And you can see I got the same answer both ways. Last one, g of f of 5. So my g function is the square root of x plus 1. My f function is x squared, and that's going here. So if I squared 5, I get 25, and the square root of 25 is 5, and 5 plus 1 is 6. Or I can do f of 5, and that gives me 5 squared, which is 25, and then g of this is equal to the square root of 25 plus 1, which is 5 plus 1, which is 6. And that's it.